All right, welcome back to Chapter 4. We're going to stay in Section 4.3 again today. Start today with a little blast from the past. The end of Chapter 3, we talked about systems of equations with three variables, x, y, and z. And you guys pulled your hair out about these for a little bit, not because you guys didn't understand, but it was usually because of an addition or a multiplication error were the two common ones that I saw a lot of, and I do see a lot when we're going through those. So I'm going to give you guys another strategy on how you can solve these. We're going to use Kramer's rule, just like we were doing with those 2x2s in the last video. We're going to do these, and I'm going to show you how to do them with a 3x3. So, unless I ask for it, you guys don't have to use the methods that we talked about in Chapter 3. You can use Kramer's rule, which is probably how I would do that. So, for a 3x3, you're still going to have to set up your coefficient matrix. It's just going to be a little bigger. So, in this case, we're going to go A, B, and C across the top, D, E, F, G, H, and I. Okay, just like before, these are all your X values, these are all your Y values, and this column is your Z values. Then, to find your X, just like we took out the coefficients of X before, we're going to take out the coefficients of X. Now we're taking out 3 of them instead of just 2, and we're going to replace them with what they're equal to, J, K, and L, and those are all going right there where our X values were. Then we take the determinant of that and divide it by the determinant of our coefficient matrix A. Then to find Y, we keep the X values in, we replace the Y value, the Y coefficients, and we keep the Z's. Find the determinant of that matrix, divide it by the determinant of our coefficient matrix A, and Z. Hopefully you guys see a pattern here. We're going to take out the Z values, leave X and Y alone from A, find the determinant of this new matrix that we've created, and divide it by the determinant of A. So not much has really changed. It's really the same process. It's just finding that determinant is going to be a little longer because it's a 3x3 and not a 2x2. So take a look at an example here. A little bit of a science connection for you, a little bit of chemistry. So I give you the atomic weights of different compounds. We're going to end up writing a system of equations with 3 variables so that we can find the atomic weight of each individual element. So we want to find the atomic weights of carbon, hydrogen, and oxygen. So yes, these will match up with what your chemistry book says. So, but just a little refresher. Remember when we've got that 4 down there, that means I have 4 hydrogen, 4 hydrogen atoms in this compound, that methane compound. So, I know that I have 1 carbon, I have 4 hydrogens, and together, I know that the atomic weight of that has to be 16. Glycerol, using my subscripts again, I've got 3 carbons plus 8 hydrogens plus 3 oxygens. I'm going to cross my O's just so I don't get those confused with zeros. That would be a terrible mistake for us to make. And the weight of that has to be 92. And water, everybody knows, 2 hydrogens plus 1 oxygen, and the atomic weight of that is 18. So, that being said, A is going to be And in this case, I'm going to line these up. Since I don't have X, Y, and Z, I'm just going to keep going with the pattern. Since I listed carbon first, I'm going to put carbon here, hydrogen here, and oxygen last. So I'm going to end up with, I have one, if I look at methane, my first equation for methane, I have 1 carbon, 4 hydrogen. I have no oxygen in there. So I put a 0 in there. I have to do that to signify that there's nothing there. I can't just leave it blank. Next one, I've got 3 carbons, 8 hydrogens, and 3 oxygens. And for water, I have no carbons, I have 2 hydrogens, and 1 oxygen. So remember, if you don't see a number in front of a variable, then that is going to be just a 1. And as always, we need to find the determinant of this, so we're going to copy down the first 2 columns. So 1, 3, and 0, 4, 8, and 2. And to find that determinant, what everybody's looking for, determinant of A. Starting at the top right, or top left, 1 times 8 times 1. Plus 4 times 3 times 0. Plus 0 times 3 times 2. And from that, I have to subtract, starting bottom left, going to top right. 0 times 8 times 0. Plus 2 times 3 times 1. Plus 1 times 3 times 4. Simplify this down a little bit. We're going to get 8 in green minus 18 in red. So it's going to be a positive 18 in red since we're subtracting those. So our determinant is going to be negative 10. So I don't know if you want to circle it, box it, underline it, whatever. Just make sure you know where that determinant is because you are going to end up using it 3 times. So now to find carbon, I'll go in blue. Okay, I need to set up a new matrix. Again, it'll be a 3 by 3. I'm going to take out my carbon numbers, my carbon coefficients, 1, 3, and 0. I'm going to replace those with what our equations are equal to. 16, 92, 18. Other than that, A stays the same. 4, 8, and 2, 0, 3, and 1. And I need to divide all that by negative 10. Now, I'm just concerned with finding my determinant from here. So, what I do is the same as we always do. Find that determinant. 16 times 8 times 1 plus, I got to copy these down. Do that in blue. 16, 92, and 18, 4, 8, and 2. I'll make it a little easier for us to calculate that. So 4, 3, and 18 plus 0 times 92 times 2. Those zeros make it really nice for us. They end up making multiplication simpler. From that, we are going to subtract 18 times 8 times 0 plus 2 times 3 times 16 plus 1 times 92 times 0 times 4. calculate that out. In the black, I'm going to get 344 minus 464 in the green. That's going to give me a negative 120. Remember, I have to divide by the negative 10 here, so I get negative 10 down below, so I'm going to get 12. That's what my carbon atom weighs. If you guys are familiar with your periodic table, you'll recognize that that is the atomic weight for carbon. Then we need to do this for hydrogen. So hydrogen was our second column of A, 4, 8, and 2. We're going to keep A exactly the same, plug in 16, 92, and 18, where the 4, 8, and 2, everything else stays the same. So my matrix ends up looking like this to find my H. And you get 1, 3, and 0, same as what it was in A. Then I'm going to get 16, 92, and 18 here, and 0, 3, and 1. Divided by a determinant of A, negative 10. That's why I like to calculate those right away. Just get it out of the way right away, early on. Copy our first two columns, 1, 3, and 0, 16, 92, and 18. And now we just start working to calculate that determinant up top. So 1 times 92 times 1 plus 16 times 3 times 0 plus 0 times 3 times 18. I'm going to subtract 0 times 92 times 0 plus 18 times 3 times 1 and 1 times 3 times 16. From there, I get 92 minus 102 to give me a negative 10 over that negative 10 from down here. We're always dividing by that determinant. So I'm going to get 1 is what my hydrogen atom weighs. Is that atomic weight? And lastly, we got to do oxygen. So again, A stays the same except for the oxygen column. That's what is going to get replaced. So I have 1, 3, and 0. I have 4, 8, and 2. Now, oxygen was my third column. I'm going to replace that with my 16, 92, and 18 here. Divide by negative 10. And copy my first columns over, 1, 3, 0, 4, 8, 2. And we get to work finding our determinant. Try and speed this up a little bit. So 1, 8, 18 plus 4, 92, and 0 plus 16, 3, and 2 minus, in green, 0, 8, and 16 plus 2, 92, and 1 and 18, 3, and 4. And I simplify all of those. I get negative 160 after I subtract them. Again, divided by the negative 10 from there. Don't forget that. And you're going to get that 16 is the weight of oxygen. Again, matches up with your periodic table. In this particular problem, I don't have a problem with you guys leaving your answers like this. If we're working with X, Y, and Z, remember I'm going to want them in that ordered triple, X, Y, and Z. All right. Hopefully this makes sense to you guys. We'll practice in class. Thanks for watching. I will see you guys later.